Hello and welcome back to part 3 of the OwlBot project. We are still currently in the prototyping phase to create the finished product of this guy. In the last part of the build, we added the DF Player Pro Mini MP3 player to our prototype circuitry. And what we did is we uploaded an MP3 file of owl sounds to that DF Player Pro Mini. We made all the proper connections to our prototype circuitry on our breadboard, and then we made the proper connections if I haven't mentioned that yet, and then we updated the Arduino code in order to get everything working as we needed it to be. So for this part of the project, our goal is to add the flashing red LED eyes for our OwlBot prototype. And what I'm going to be using is a couple of flat top clear lens red LEDs, and they happen to look like this. I will add an image of these later on so you can see them better up close. But I chose to use these flat top clear lens red LEDs because I thought they might look better when I plan on adding them somewhere on the owl's face, around the eyes somewhere later on in the project. And I figured that having these clear lenses like this would be a little better, less inconspicuous than having your typical rounded lens red LEDs that might look like, I don't know, a couple of sore thumbs sticking out of the face of this owl, or might even look like a couple of ticks or something. But that's the reason why I'm choosing these type of LEDs. You can choose whatever type you'd like, and I happen to like the flat top design. That looked pretty neat to me, so that's what I'm choosing for mine. You can choose whatever type of LED you'd like to put on your OwlBot, or even any color you'd like to use. I just happen to be using red. Red's a common color in LEDs. So I'm going to put this guy off to the side over here. I don't need him right now, but that's, like I said, I'm using the flat top clear lens red LEDs, and this is going to be a pretty short video. There's not much to this part in adding the ability for the flashing red LED eyes for the OwlBot. We just need a few more extra components. Like I said, we're going to be using a couple of the LEDs. All I need is a couple of resistors. I happen to be using 680 ohm resistors, and those will act as our current limiting resistors for the LEDs. And then I need a couple of jumper wires, and that's it. And then after we add those components to our prototype circuit on our breadboard, then we'll just need to update the Arduino code from the last part of this project, and hopefully everything will be working as it should. So let's go ahead and get into that step right now. Okay, as you can see, I have the breadboard set up here. Again, I'm using the ultimate DIY 3220 point breadboard. It's made from a previous project I did. You can check out all the details that I'll leave in the description below. Everything here is set up is exactly like we left off in part 2 of the OwlBot project series, all except for this new label here, or sticker here, where I have TUDIY introducing herself. TUDIY is just the acronym for the ultimate DIY 3220 point breadboard, this piece right here. And I name it TUDIY for short because it's kind of a mouthful to have to say the ultimate DIY 3220 point breadboard every time I mention this thing. So I call her TUDIY, and here she is introducing herself. Hi, I'm TUDIY. Anyways, let's get back to the project. Again, I'm only going to be using a few components here for part 3 of this OwlBot project series. I'm using 2 flathead clear lens red LEDs. I'll be using 2 680 ohm resistors, and I only need 2 jumper wires, and I'm using orange jumper wires. So let's get right to it. We're going to install the LEDs first, and I'll just go ahead and leave those resistors right there. So I'm going to take LED number 1, and what I'm going to do is I'm going to place its cathode on the negative rail here of my 5-volt power supply, the negative rail that we set up earlier on in the project. And I just need to make sure, I'm going to move the light here. I just need to make sure that I get the orientation correct on the LED, and I need to, the negative lead is this straight leg on my LED here, and the way you tell that it's the cathode or negative leg of the LED is that lead or leg attaches to the larger lead inside the casing of the LED, and I call it the fat flag. That just helps me remember that that is the negative lead of the LED. So in my case, I'm taking the straight leg of this LED, that's the cathode or negative lead of the LED. I'm going to place it into a point on the negative rail of the 5-volt power supply, and I'm going to place the anode into point A15 on my breadboard. So the point that I'm going to see if I can zoom in here. The point that I put the positive lead or anode of the LED into is at point A15. And I'll give a close-up shot of this here in a little bit after I install the LEDs, resistors, and the jumper wires. So I'm going to zoom back out for now. I'm going to grab my second LED, and again, I'm going to take the cathode of the LED, place it into a point on the negative rail of the 5-volt power supply, and I'm going to place the anode or positive lead of the LED. I think I'm putting it at point A19, so just like so. Now we're going to move on to the resistors. Again, I'm using 680 ohm resistors, and that is the color blue, gray, brown. If I can get it to focus. There we go. Blue, gray, brown. I'm going to put it down onto the board here. And again, resistor orientation doesn't matter. I think I'm just going to have my gold bands face toward the LEDs just to make it look a little nice and neat. And I'm going to place my resistors, I'm going to place one lead of the resistor on point, let's say C15. If I can see what I'm doing here, I'm going to use my tweezers. So I'm going to place one resistor at point C15 in line with the resistor that I placed on the board first, and then the other lead is at point F15. So again, I have my first LED where its anode is at point A15. I have this resistor in line with that LED at point C15, and the other leg or lead of the resistor going across to point F15. I'm going to take my second resistor and I'm going to place one lead at point C9, 19, and then the other lead of the resistor at point F19. So again, for this second resistor, I've put it in line with the second LED we placed into the breadboard. So the anode of the LED of the second LED is at point A19. The second resistor is in line with that LED at point C19, and the other leg or lead of that resistor goes across to point F19. So now we have both the LEDs in place, both resistors in place. Now I just need to make the connection from the resistors to the Arduino. So I'm going to take one of my orange jumper wires. I'm going to place it in line with the first resistor at point J15. I'm going to place the other end of that jumper wire to pin 4 of the Arduino. So pin 4 will be right there. And then I'm going to take my second jumper wire. I'm going to place one end of the jumper wire in line with the second resistor at point J19, and the other end of that jumper wire to pin 5 of the Arduino, like so. So let me get you a close-up view of this, and then that way that you could see it a little bit closer. Okay, I got you at a close-up view now, and I'm going to kind of turn the breadboard a little bit so we can see a little bit better. So just to review what we just did for this part, where we've added the 2 LEDs. I have this first LED that I placed in, I have its cathode lead or negative lead into the negative rail of the 5-volt power supply. I have its anode or its positive leg at point A15. In line with that is our first 680 ohm resistor. It has one of its leads at point C15. Its other lead goes across over to point F15, and then in line with that is this first orange jumper wire that's in line with that resistor at point J15, and it goes over to pin 4 of the Arduino right here. You can see that. That's this jumper wire here. And then our second LED, again, we put the cathode or negative lead into the negative rail of the 5-volt power supply that we set up in a previous part of the OwlBot project. And we have the positive lead or anode of the LED going to point A19. In line with that is our second 680 ohm resistor. One of its leads is going into point C19, going over across to point F19, and then in line with that resistor is our second orange jumper wire, and one of its leads is in point J19, and the other end of this jumper wire goes over to pin 5 of the Arduino. If I can move that so you can see right here. So that's this jumper wire here, and that's it. So the next step we need to do is update our Arduino code so that we can get these 2 LEDs to blink when motion is detected by the peer sensor. So the goal is we want the 2 LEDs to start blinking at the same time the MP3 player is playing the owl sounds that we set up in part 2 of the OwlBot project. We want those to go at the same time when motion is detected by the peer sensor we added in part 1 of this project. So let's go ahead and update that code now, and then we'll test that code out and hopefully everything will work. Okay, I have the Arduino code up here on my screen. So all we're going to do is, I'm going to update a few things in the previous code that we had in part 2. So if you need to check out what all this other stuff is in the Arduino code, go check out part 1 and part 2 of the OwlBot build series. As I said, we're just going to check out the things that I've updated for the LEDs that we've added to our prototype circuit for the OwlBot project. And looking at near the top of the code here, we can see at lines 49 and 50 that there is 2 new variables here, and one I've named left eye and I've set it equal to 4, and this is going to represent the one LED that's at pin 4 on the Arduino, and I'm just arbitrarily saying that that is the left eye. And similarly, I've named the other variable right eye for the other LED, and I've set it to 5, which represents pin 5 on the Arduino. And again, I've arbitrarily called that the right eye. Next, if we look down in the setup, we can see that we've set up the pin modes here for both the left and the right eye. And I've initialized those 2 variables to be outputs because we want to output to the LEDs to turn them on or off. Next, we can see these where I have initially turn on or turn off both of the eyes. So initially we want to turn both of those LEDs off, or make sure that they're both off when the program initially starts. So I've called the digital right function for both the left and the right eye variables, and I've set both of those to low just to make sure that when everything first starts up and running that the 2 LEDs are off, because I don't want them on as soon as I put the power into the final OwlBot project. Now, coming from lines 63 and 64, we're going to jump down to line 121, which is inside the play_al function. So if I refer back up to our loop function, originally we had it to where this motion status variable, it is initialized to a digital read function, and what it's doing, it's listening for the peer variable to tell us whether or not the peer sensor has detected motion or not. And if it does detect motion, then it'll jump down into this if statement here, this one. And inside this if statement, it'll check to see if the peer state is low. And within this if statement, there is a third if statement, and what it's saying is if the sound effects player is not playing, then we want to play the sounds, and it calls that play_al function. Again, if this is confusing to you right now, this is what we set up in part 2 for the OwlBot prototype circuit when we put the MP3 player onto our prototype circuitry. This is what this particular if statement is for, and some of this other stuff. We did all that in part 2, and I'll leave the information for that video down in the description. But anyways, we can see that we're calling the play_al function here, and inside the play_al function, we see here on line 121 that this call to the blink eyes function is made. And from here, it will jump down to the blink eyes function. This is a function that I created. And what it does is that once it gets inside here, it delays or waits for 250 milliseconds or a quarter of a second, and then immediately goes to this first for loop here. And in this for loop, I've initialized a variable called I equal to 0. And if I is less than 10, we want to go in the for loop. And within that for loop is another embedded for loop within the first for loop. And here I have another variable initialized. It's called J, and it's initially set to 4. And if J is greater than 0, we want to go down into this second for loop, and we want to call the digital right function for both the left and the right eye. And what it does is it turns the two LEDs on to high. So that is turning the LEDs on, both the left and right eye. And then we're going to wait or delay for 125 milliseconds, or about 1/8 of a second. And then we want to again call the digital right functions for both the left and right eye and set those to low, or what we want to do is now turn those LEDs off. And then again, we're going to call the delay function, and we want to wait about another 1/8 of a second, and then it'll run back through this second for loop here after it's already decremented the value of J. So we started at 4, it decrements the value of J by 1. Now when it comes back up, J will be equal to 3. 3 is greater than 0. Again, we'll go in here, turn both the left and right eye on, wait 1/8 of a second, turn both the left and right LEDs off, wait 1/8 of a second, and do it all over again until J is no longer greater than 0, and then it'll go back up to this first for loop, and I is incremented here to 1 this time. When it starts at 0, when it comes back up here again, it'll increment it to 1 or by 1. And as long as I is less than 10, it will keep going back to this second for loop, and this for loop will continue to go until J is no longer greater than to 0. And then when it isn't, it'll leave and go back to this for loop. And all of this occurs over and over again for some period of time, just enough time to have the eyes blink long enough. It's just you can change these variables to whatever you want. These happen to be the values that I wanted to choose, that I felt that I wanted my OwlBot's eyes, the red LED eyes, to be blinking. I don't recall exactly how long this is, but you can change the variables however you want. And then once all this is said and done and it's finished, it leaves both of the for loops. It will leave this blink eyes function and go back up to line 121, where it will continue the rest of the code. So that's all that I've added to the code from part 2. This is the updated code for the OwlBot for part 3 of our OwlBot series. So I'll leave the link to this code to where you can just copy it and paste it into your Arduino IDE if you're following along in this project, to make things easier for you so you don't have to type it all up if you don't want to do that. And now all that's left to do next is just upload this code into the Arduino. I'll go ahead and upload it now. And then once that's uploaded, we'll go check out and see if everything's working. Okay, I have you up close to the prototype circuit again, and we've already just uploaded the code, the updated code for the Arduino. Again, what we've done for this project is we've added the 2 LEDs that will represent the OwlBot's red flashing LED eyes. We've added the 2 current limiting resistors in line with those 2 LEDs, and we've connected our components to the Arduino board to pins 4 and 5. So I haven't turned anything on yet because I didn't want it to start making sounds and stuff while I was talking. I've already got the power plugged into the Arduino from TUDIY's power supply, the 9-volt power supply over here. I'm going to go ahead and turn the power on now, and then we'll test to see if we're making sound still, and then now hopefully having the red flashing LED lights. I'm going to wave my hand in front of the motion sensor. It picks it up. And now we have the owl sounds coming from our speakers that we set up in part 2 of the OwlBot project. And we also now have, if I can get it to do it again, I think because it's a weird position maybe. And now we also have the red flashing LEDs. This will be the eyes of our OwlBot in the finished product of the OwlBot. So it looks like our progress is looking pretty good so far. In part 1, we added the peer sensor for motion detection. In part 2, we added the speakers and the DF Player Pro Mini MP3 player to add owl sounds to our prototype circuit. And now we have our 2 flashing red LED eyes for our OwlBot project. I hope that you enjoyed this part of the project, and I really hope that you stick around with me until the completion of this project. I really appreciate you watching, and I will see you in part 4 of this OwlBot project series. So remember, keep at it and stay motivated. I'll see you next time.